Okay, so as you can see, what we were given from the problem was that at 6 p.m. the temperature of the object, which is the body, is going to be 80 degrees Fahrenheit, and then at 7 p.m. the temperature of the object is 75 degrees Fahrenheit, so we know that it dropped 5 degrees, and that is in a 60-minute interval. And then the ambient temperature, which is the constant temperature, is going to be the temperature of the room, which is 70 degrees Fahrenheit. And even though it wasn't given, we know that the average human body temperature is 98 degrees Fahrenheit, which we need to know for later. So, and then our equation is going to be T of T, which is time. So the temperature of at a certain time equals the temperature of the ambient plus the temperature of the object minus the temperature of the ambient, and then e to the negative k times t. So k is going to be the constant decay coefficient. And to find k, what we first have to do is find what the temperature was after like the time of death, I guess, or after the time of discovery. So what we're gonna do is, since 60 minutes passed, we're gonna put T of 60, and then we know that that equals 75 degrees Fahrenheit. Okay, so then we're gonna put 75 on the left side of the equation, and then the ambient temperature is 70, and then we're gonna add that to 80 degrees Fahrenheit minus 70, and then that's going to be e to the negative k, and then t should be 60. Okay, so then next what we have to do is we have to add what's in the parentheses first, and that's going to be 10. So if we rewrite the equation, it's going to be 70 plus 10 to the e negative kt, or 60. Okay, next what we need to do is subtract 70 from each side, and that's going to be 5 on this side, and that's going to equal 10e to the negative 60 times k. I just rearranged it so it would look more natural. Okay, and then next we're going to divide 10 by each side, and that should be 1/2. So it's going to be 1/2 equals e to the negative 60k. And to get rid of the e, we have to multiply each side by the natural log, because natural log and e are equivalent, so they cancel each other out. So ln of each side, and so that's going to cancel out. So then natural log of 1/2 is going to equal negative 60k. So next we have to divide the natural log of 1/2 by 60. By negative 60 actually. So then after we calculate that, k is going to equal 0.011552453. I'm not going to round to the end because that could actually change our answer. So we know that k equals 0.011552453. Okay, next we have to find the time elapsed between the time of discovery and the time of death. So we know that it was discovered at 6 p.m. and at 6 p.m. the temperature of the body was 80 degrees. So we're going to go ahead and put 80 on this side, and then the ambient temperature is going to be 70 again. But this time we're going to use the average human body temperature, which is 98.6 degrees Fahrenheit, because his body, unless he was already dead whenever he was killed, his body should have been at normal temperature, because 80 degrees is really, really low. So it should have been 98.6 degrees Fahrenheit. And then we're going to subtract that from the room temperature, and then same equation. This time we actually know k, but it's kind of long to write it out, so we're not going to write it out to the I'm not going to write it out to the very end. Okay, so then next what we would do, we're going to go ahead and add what's inside, or subtract what's inside the parentheses. So if we rewrite the equation, it's going to equal 70 plus 28.6 e to the negative kt. And so after that, and then we're going to subtract 70 from each side. So going to be 10, and then that's going to be 28.6 e to the negative kt. All right, and then so after that, we could either, well, we're going to go ahead and divide 28.6 by each side. So 10 divided by 28.6 is going to be 0.3496, and then that's going to be e to the negative kt on this side. So we're actually trying to find t right now, and so just like the last equation, what we're going to do is take the natural log of each side to get rid of the e. So those will cancel out, and then we really don't need to find the ln of this just yet because that kind of makes things a little bit confusing. So we're going to leave it like this, even though we're going to have a variable later. So negative k times t. So if we divide negative k by each side, then that is going to equal 90.96. It's going to equal the time. So that's how many time in minutes elapsed. So that's about an hour and a half. So if we round that to the 10th, it's going to be t equals 90.9. We'll go ahead and label it as minutes. That's the time elapsed. So this is the second answer. Now that we know the time that elapsed from the time of discovery to the time of death, we can figure out the approximate time that Mr. Fees was killed. Okay, so the body was discovered at 6 o'clock p.m., right? So here's part C. So since the body was discovered around 6 o'clock p.m., right? And if the time elapsed was about an hour and a half, so if we subtract an hour from this, minus 1 hour, it's going to be 5 o'clock. And then if we subtract another 30 minutes, or let's see, yeah, another 30 minutes, then it's going to be 4:30 p.m. So the approximate time that Mr. Fees was killed was 4:30 p.m.